We are going to show two different epoxy cement preparations in the obturation of a mandibular molar and a maxillary bicuspid. Here the canals have been shaped and the medium gutta percha points are trial seated in the canals. They all have significant tugback. To make a video tape, I am showing you a precise sequence that can be repeated over and over again. As you see, I place 4 scoops of powder and 6 drops of gel. This makes a mix that has low viscosity, no granularity on the surface, and a sheen to its surface. The 2-to-3 ratio of powder to gel makes a flowable cement that has high radio opacity. While the above is good for a demonstration, in reality I simply place enough powder on a glass slab for the obturation of the tooth in question. I then dispense enough gel to make the flowable cement to the desired consistency. The ratio is a guide, but a wide margin of acceptability exists with epoxy resin cements that preclude the need for precise drops and scoops. Either way will work. Epoxy cements have a property where the application of minimal heat increases the flow significantly. Rather than use heat, I would simply apply more gel, but that would make the mix less radio opaque. Under any circumstances, the applied heat is minimal and the cement, when applied to the canals, is cooler than body temperature, meaning it will expand a small amount as it warms to body temperature. We peak the cement up with the spatula and then apply the cement into the canals using the bidirectional spiral 3 millimeters short of the apex. Please note that the cement is fully loaded onto the spiral, nothing skimping with the amount of cement placed. To show you how the bidirectional spiral prevents the extrusion of cement over the apex, please note how the spinning spiral produces an ellipse of cement a few millimeters up from the tip of the instrument and drives it laterally against the walls of the canal rather than driving it apically into the periapical tissues. The cement action occurs when the cement is placed into the canals. The spiral is fully loaded and introduced 3 millimeters short of length. Several up and down strokes are used as it rotates clockwise. Each canal gets 2 full loads of cement, each applied with 6 to 7 vertical strokes. You may note that the pulp chamber is flooded with cement. This is usually no problem and the excess cement in the chamber acts as a well of cement. However, if you feel you cannot find the canals with ease, you simply take a small ball of cotton and wipe out the excess cement in the chamber, letting you see the orifice openings of each canal more clearly. Each point is then liberally coated with cement and introduced into the canal. You know you have applied enough cement if excess escapes from the canal when you place the well-coated master point. Here you see me placing all 3 points at one time. In reality, after all the canals have been flooded with cement, I will place a point and burn the excess off at the level of the orifice before proceeding to cement the next point. As you can see, the canals appear to be well filled with no voids using 3 single gutta percha points. The use of the bidirectional spiral takes the burden of a successful obturation away from the gutta percha point and places it on the cement interface where it truly belongs, because it is only the cement that has the properties required to seal the canals. The cement and gutta percha expands as it warms to body temperature. The cement bonds to the dentin and the gutta percha chemically and physically. The main purposes of the gutta percha are as a carrier and a driver of the cement. Secondarily, it offers a soft central core that allows for easier retreatment if required and the creation of a post space should that be needed. Up to this point, we have shown the application of our original Easy Fill epoxy resin cement. While we still have this cement, we now also have a second generation Easy Fill cement called the Easy Fill Xpress. It consists of 2 gels that can be auto-mixed or placed on a glass slab in equal lengths and easily mixed with a spatula. I prefer dispensing the gels in the unmixed state and mixing them myself, or more likely with the aid of my assistant. It takes about 20 seconds to mix thoroughly. The 2 gels are naturally less viscous than the powdered gel product and rarely needs heating, although it can be done. The cement is applied to the cuspid that I videotaped for a different presentation by loading up the spiral and using 6 to 7 strokes, 3 millimeters short of length, to coat the canal walls. We apply a full load of cement 2 times to the canals. Only when the well-coated master point is placed does some cement escape apically. There is so little apical force generated on the cement that if an intact PDL exists, pressure on the cement is insufficient to violate the ligament. If a PDL does not exist, some cement will be expressed periapically but will cause no post-op pain and be resolved within 6 months. Again, empirically, the occasional excess cement under these conditions has not presented a clinical problem. Because this canal is wide buccolingually, I use a spreader with a force never exceeding the weight of my hand to create a lateral space for the placement of additional well-coated gutta-percha points. I may add one or more depending on how oval the canals are. Obviously, the more oval, the more lateral points placed. The more points I place, the more shallow the spreader depth of penetration for each subsequent point. The important point to remember here is to never exceed the weight of your hand as the force applied to the spreader to create a lateral space for each subsequent point. Below, you will again see the starting X-ray, trial fit, and various stages of obturation.